Hello students, in our last module we have studied about how to separate salt from water via evaporation. You saw that the water on getting heated by sunlight or flame of a burner, it slowly turns into water vapor. And after the evaporation of water is done, we are left with solid salt particles. But students, if we want both salt and water separately from the mixture of salt and water, then which method should we use along with evaporation to get back water from water vapors? Just think about it. Okay, so to answer this question, I need to give you a brief introduction of water cycle. So let's discuss water cycle now. So in a water cycle, the sun's rays during the day, they heat the water bodies such as oceans, rivers, ponds, etc. And the water from the surface of these water bodies, it gradually keeps going into the air in the form of water vapor. And such a process is known as evaporation. Now, as the moist air moves up, it gets cooler and cooler. And at sufficient heights, the air becomes so cool that the water vapor present in it condenses to form tiny water droplets. Now these tiny drops of water, they accumulate together to form clouds. Now soon these water droplets, they become so heavy that they begin to fall down. Thus the water which had gone up in the form of vapor now comes back to the ground in the form of rain, hail or snow, and this process is known as precipitation. Similarly, when we heat salt water, water turns into water vapor and it gets mixed with the air surrounding it. Now just think, how can we get this evaporating water back with us? Well, for this, we have to think about something which can condense the water vapor back into its liquid state. So students, as we have seen in the case of water cycle, where the water vapor on coming in contact with the cooler air, it condenses to form tiny drops of water. So now what can we do to get the evaporating water back into its liquid state? Let's perform a simple activity and see whether it is helpful in condensing the water vapor back into its liquid state. So students, you can observe here that I've got a conical flask which is almost half filled with water. And on heating it for a while, you can observe that the process of evaporation, it becomes faster. You can also see the water vapors coming out of the flask. Now we've already studied that the process of evaporation, it can occur at any temperature from 0 degrees Celsius to 100 degrees Celsius. But then you must remember that the rate of evaporation, it increases on increasing the temperature. And how does this mechanism occur? That is something you will be studying in your higher classes. But till now, we have observed that on providing heat to water, water changes into water vapors or steam at a very fast pace. And these vapors, they move upwards. Now what do we want next? Yes, we want this evaporating water back. So how do we get it back? So to get it back, a metal plate is held in a tilted position just above the mouth of the conical flask. You can see here. Now a wide mouth beaker is placed under the lower end of this metal plate. And why is this beaker held here? That is to collect the condensed water. So what do you observe here now? Well, the water vapor or steam coming in contact with the cold metallic plate, it condenses to form liquid water. And this liquid water then begins to fall from the plate into the beaker. Now the water droplets that you observe falling from the plate, they are due to condensation of steam, where condensation is nothing but the process of conversion of water vapor into its liquid form. So this is how we can make use of combination of two methods, that is evaporation and condensation, to get salt as well as water separately from the mixture of salt water. Now students, can you give me an example of condensation from your daily life? Okay, so when we cover the boiling milk with a metal plate, then you must have observed the formation of water droplets on the lower side of the plate. Let me show you. So there you can see the tiny droplets of water formed on the lower surface of the plate. Now my question to you is, how do these water droplets they form under the plate? Just think about it. Correct. It is due to the condensation of steam coming in contact with the cold surface of the metal plate. These vapors, they condense to form water droplets like these. Now another question that I want you to ponder upon is, why do we get water droplets on the lower surface of the metallic plate? And why not milk droplets? After all, we were boiling milk only. So before I provide you the answer to this question, let me tell you about the composition of milk. So milk is a mixture of fat globules within a water-based fluid that contains dissolved carbohydrates and proteins along with minerals. Now when we boil milk, then only the water content gets converted into vapors, while the other components such as the fat particles, the minerals, the proteins, etc., they remain in the concentrated milk.